Myself, MGB Saideja. I am pursuing second BTech in VVITU University. My roll number is 24BQ1804A2. I want to tell the seminar topic joint probability. The contents of joint probability are: first one, introduction; second one, definition; third one, formula; fourth one, diagram; fifth one, example. The introduction about the joint probability is: what is joint probability? Joint probability refers to the likelihood of two events happening at the same time. This means the probability that event A and B both occur. Joint probability means two events happen at the same time. Second one, definition. Joint probability refers that probability of two events happening at the same time. It tells us likely it is that both events occur together. Joint probability is the probability that event A and event B both occur at the same time. It is commonly expressed as P of A intersection B or P of A and B. Third one, formula. Mathematically, for two events A and B, the joint probability is written as P of A intersection B or P of A and B equal to P of A plus P of B minus P of A union B. That means the probability that both A and B happens. Fourth one, diagram. Joint probability diagrammatic representation. When the total box is universal set, considering as the X, A is the one of event and B is also another event. When the joint probability indicates the when the both events having common elements, that common elements is represented by joint probability. Visual representation. Joint probability can be visualized using a Venn diagram where the intersection of circles represent the simultaneous occurrence of two events. Key points. Joint probability measures the chance of two or more events happening together. It is foundational for understanding intersection in probability and for building statistical model involving multiple variables. Formulas differs based on whether the events are independent or dependent. Fifth one, example. Suppose we toss the two coins randomly. Event A, the first coin shows head. Event B, the second coin shows head. Solution. Now the sample space is a sample space set of head, head trail, trail. Probability of each outcome is 1 by 4. P of A intersection B equal to P of first coin equal to H and second coin equal to head equal to 1 by 4. A classic example of joint probability is finding the likelihood of getting a specific result when rolling two dice, such as both dice showing a 3, since each die is independent. The probability of rolling a 3 on the first die is 1 by 6. The probability of rolling a 3 on the second die is 1 by 6. The joint probability of both events happening is 1 by 6 into 1 by 6 equal to 1 by 36. Example. Independent coin tosses. Event X getting a hit in the first toss, P of X equal to 1 by 2. Event Y getting a tail in the second toss, P of Y equal to 1 by 2. Joint properly. P of X intersection Y equal to 1 by 2 into 1 by 2. That equal to 1 by 4. Another real life example. Event A, student studies English. Event B, a student studies physics. If in a class 100 students, 40 study English, 50 study physics, 20 study both English and physics. Additional everyday example, insurance claims. In an insurance business, consider the probability of a customer filing a claim 0.1 and then receiving a payout given the claim was filled 0.8. The joint probability they file and get paid is 0.1 into 0. Equal to 0.08 or 8%. Weather and promotion. Suppose an employee expects a 85% chance of getting a promotion and a 30% chance of rain The joint probably they get promoted and it rates the same day is 0.85 into 0.3 equal to 0.255 or 25.5. Detailed example. In a computer store selling both PCs and Macs, if 87 out of 23 customers are females, buying Macs, the joint probability of a randomly chosen customer being a female and buying a MAC is 87 by 223. Another real life example. Even A student studies English, even B student study physics. If in a class of 100 students, 40 study English, 50 study physics, 20 study both English and physics. Joint probability in weather forecasting is used to determine the likelihood of two or more weather events occurring together, such as the probability that it will both rain and be windy on the same day. Applications in weather forecasting. Meteorologists often calculate the joint probability of events like high temperature and precipitation to better estimate complex scenarios. For example, the chance of both rainfall and a thunderstorm on a specific afternoon. Joint probabilities help combine forecasts for individual phenomena like rain and wind into a single forecast for their co-occurrence, defining decision making for the public and sectors like agriculture or travel. Practical example. If there is a 60% chance of rain, P of rain equal to 0.6 and 30% of chance of high winds, P of wind equal to 0.3. And these events are independent. The joint probability of both rain and high wind is P of rain intersection wind equal to 0.6 into 0.3 equal to 0.18. This means there is an 80% of chance of experiencing both conditions at the same time. In summary, joint probably enable more accurate and actionable weather forecasting by considering the combined impact of joint uncertainty on forecasts. Joint uncertainty in forecasts refers to the combined impact of uncertainties from multiple sources or variables, like temperature and precipitation, on prediction accuracy. In weather forecasting, taking joint uncertainty into account allows models to portray a more realistic range of possible outcomes rather than just individual probabilities per single events. Impact on weather forecast. More accurate risk assessment incorporating joint uncertainty. Example, the likelihood of both heavy rain and strong winds provide a broader and more accurate picture of risk, especially for compound extreme events. Ensemble and probabilistic forecast. By using ensemble methods and joint probability modeling, meteorologists generate a distribution of possible outcomes. This practice quantifies the range of forecast uncertainty and supports probabilistic forecasting for decision making rather than relying on a single deterministic outcome. Ensemble and probabilistic forecasts. By using ensemble methods and joint probability modeling, meteorologists generate a distribution of possible outcomes. This practice quantifies the range of forecast uncertainty and supports probabilistic forecasting for decision making rather than relying on a single deterministic outcome. So the conclusion of joint probability is joint probability plays a crucial role in enhancing the accuracy and usefulness of weather forecasting by capturing the combined likelihood of multiple weather events occurring together. Modern forecasting models that incorporate joint probability and joint uncertainty are able to better represent the complex spatial and temporal dependency inherent in weather patterns. This leads to more skillful probabilistic forecasts that improve risk assessment and decision making for various sectors affected by weather conditions. By modeling the joint distribution of weather variables such as temperature, provide a holistic picture of potential weather scenarios rather than isolated. Advanced methods including machine learning model trained on joint probabilities have demonstrated significant and covariance of weather variable across different locations and times. These improvements allow for finer resolution and longer range forecast, better representation of uncertainty and risk. So these are applications of joint probability, and I will end my seminar topic joint. Thank you.